Good morning. Hi. So I'm sorry, I was just coughing. Um, hi. We're going to look at stoichiometry. Going to try to put some twist on it to make sure that you understand how to handle, whatever, and just really understand the process. So I'm going to go ahead and share my screen. I'm probably going to make 3 different stoichiometry videos, to be honest with you. This here will be the first, and this is going to focus on solution stoichiometry. Okay, so solution stoichiometry, just a lot of math. I guess I need to pull out my periodic table and my calculator. Okay, I have a practice question here. So if you want to go ahead, actually, I'm just going to come in here with you. This question will evolve as you write it down. So we've got silver nitrate. It's a solution. Let me make my pen thinner, maybe. Oops, sorry about that. Silver nitrate. That's not thinner. Is the solution. And I've got it's reacting with the sodium carbonate. Okay, and that's a solution. And I'm going to get the silver carbonate. That should be my solid. And I'm going to get some sodium nitrate, and that will definitely be dissolved in the solution that remains. Okay. Write the chemical equation and the net ionic equation. Okay, well, I'm going to do this pretty quickly. I'm going to have the silver ions, the nitrate ions. I can already see, guys, I'm going to put a 2 here. I can already see what this will be. Hopefully you can too, right? Basically, what's left over is going to be what forms my precipitate. You do not need to show this step. You do not need to show this step. I'm only showing this step because I'm leading, there might be students out there that are confused. So when I get what's left over is this right here, and that in fact is the equation that you would be expected to write. Okay, probably nothing else but that right there. You do not need to show the rest unless it is asked for. You do need to know what your spectator ions are and what that means. Okay, now let's get to the math of this, and hopefully it's been a long morning, so hopefully I can focus on the direct, easiest approach here. I'm actually going to get rid of like this and this and this and this. And I'm going to write what I have here. I've got 25, oops, let me get my pen. I've got 25.0 milliliters of this, and there's a 0.150 molar. I've got 25 point, no, wrong place. Let's put that over here. I've got 25.0 milliliters of this, and it is also a 0.150 molar. I need to identify the limiting reactant, prove it with a calculation. I need to determine the mass of the precipitant, that is grams, and I need to determine the concentration of all ions remaining in the solution after the reaction is complete. Now, I posted one way to do that, and I'll be honest with you, I removed that video. One of you watched it. I'm wondering who it is. I feel like I know who it might be. Well, it's one, I know. Tell me who you are. And I didn't like it. So I'm going to do this a different way. But if you, that one of you, think that the other way was better, let me know. Okay, so let's get started here. We need to know the concentration of all ions in solution. That will be the last thing. But since I know, I'm going to take a different approach here than the other video. Since I know that they're asking me the concentration of all ions in solution at the end of the reaction, I am going to go ahead and figure out how much I'm starting with. So, let me get my picture out of the way so that I can know how much I ended with. Okay, So let's go ahead and get the concentration of all ions initially. All right, concentration, all ions initial. You know, and you could go ahead and pause. That would be cool, and do your work and then fast forward and see if you get the same thing. Okay, so let's look at our Ag ion. Well, we've got 25.0. Actually, let's see. I'm going to go ahead and do the silver nitrate and then go about it that way. So we've got the 25.0 milliliters. We would have to divide that by 1,000, either in our head or with, you know, however you want to do it. And then that's our molarity. All right. So I do have a calculator here. It would be what, 0.025 times 0.15. And that's 3.75 to the negative third times 10 to the negative third moles of AgNO3. And I'll just go 1-to-1 ratio. Therefore, 3.75 times 10 to the negative third moles silver and 3.75 times 10 to the negative third moles of nitrate. So I know that's how much I started with. Now, look up here, I've got 25 milliliters of a 0.150 molar Na2CO3 solution. So when I do the math there, I will also have the same numbers, right? I'm just going to go ahead and write it. 1 liter, and this time it's 1 liter and it's 0.150 moles. And that's going to give me the same answer because it's the same numbers. This time it's moles of sodium carbonate. We have a 2-to-1 ratio. So 3.75 times 10 to the negative third moles times 2. Put that in my calculator. What's that? 7.5? Yeah, 7.5. Keep your sig figs to 0, negative third moles of sodium ions. And we have 3.75 times 10 to the negative third moles of carbonate, and that is a 2 negative ion. So this is initially what's floating around in the solution, kind of like at time 0. Okay, so that's at time 0. This is our initial concentration of all ions. Notice that I did show my work and I used something to prove what I was, you can follow. Why did I multiply it by 2? I showed that I did multiply it by 2, right? All pretty quick, but nice and organized, and it's easy to understand why what is happening, okay? So I've shown my work and every thought process. Okay, now, what's cool here is let's look at a couple things. And what I'm trying to do is just build understanding. Some of you probably already have this understanding, but we have 2Ag. This was our actual reaction, right? Plus CO3, 2 negative, formed Ag2CO3. So right here, I'm going to go ahead and, I need to identify the limiting reactant. Well, let's go like this, guys. This is my reaction. So let's just look at this. I have silver ions, 3.75 times 10 to the negative third. And carbonate ions, right here, same number, 3.75 times 10 to the negative third. Well, I have to show my work, right? I can visually see right now what is my limiting reactant, because I see that every one requires 2. So on my exam, when they say identify the limiting reactant and prove, if it doesn't say with a calculation, you don't need one. Justify means you do not need a calculation. So I'm going to assume that up here, I'm not going to assume, I'm the teacher. I'm going to change it. I'm going to say justify. That means you can use a calculation or you can explain. Most students prefer the calculation that they were taught in gifted chem, where they go from reactant to product. They compare the smallest answer, whichever reactant produced the smallest answer. They identify that as their limiting reactant. It takes longer, but it's tried and true. Students do it, love it, don't make mistakes. It's cool. But I'm just going to give you a quicker way. I see that it's a 2 silver ratio to a 1 carbonate ratio. I have a 3.75 times 10 to the negative third moles to 3.75 times 10 to the negative third moles is what I have, right? Well, what I would need based on my molar ratio, right? Or that's not molar ratio, it's kind of more like a mole ratio. It would sound better. It would be twice as many. I would need this, right? And I would need this. So what I can visually see based on the ratio up here is that I need 2 silvers for every 1 carbonate. Well, what I have is 1 silver for every 1 carbonate. So that tells me right now that this is my limiting reactant, right? I can already identify that this is my limiting reactant. Now, if that did not work for you, let's look at it a different way. And if it did, I apologize for this. You can fast forward if that's up to you, right? Answer all the questions, check your work. I could go 3 or, right? 3.75 times 10 to the negative third moles of silver, 2 moles of silver for every 1 mole of silver carbonate. There's so many different ways you can do this, guys. Well, that would make, what's half of 3.75? 1.625. Oops, shoot. 3.75 second E negative 3 divided by, divided by 2. Is that 1.875 equals 1.875 times 10 to the negative third moles of silver carbonate. And then we would go from, that's from here to here, right? And you would go from here to here. Hopefully you can see it in your head. It is a 1-to-1 ratio. Therefore, the answer is what I'm writing right now, right? There's 1 mole of carbonate relates to 1 mole of silver carbonate. Therefore, we have, oops, there's not a negative there. Therefore, we would be able to make 3.75. So a lot of you were taught this method. It is longer. It's tried and true. There is another way you could go about this and another way you could go about this. But basically, I have enough silver to make 1.8 moles of the compounds. I have enough carbonate to make 3.7 to the negative third moles of the compound. That's negative 3 as well. Thus, the silver here is limiting the amount of product that I can make. This is my limiting reactant. This is my theoretical yield. So most students like to take this approach here. But if you're on a multiple choice problem, it's almost easier to look at it the other way. I hope you can see it that way. What is positive about this is I've got my theoretical yields. So let's look at our question. Identify the limiting reactant. We did justify. And the limiting reactant was our silver ion. We have our work shown. Determine the mass of the precipitate. Well, we know that we're going to have, this is our theoretical yield here, right? By theoretical yield, we mean in a perfectly run experiment, we should obtain 1.875 times 10 to the negative third moles of the silver carbonate. The question specifically asked for mass, right? So we need to make sure we answer what was asked of us. Silver is 107. This is going to be a heavy compound. 0.87 times 2 plus the 1201 for copper plus the parentheses 16 times 3 for oxygen. Make sure you do it right. I've got 275.75. If I was on a test, there's a good chance I would do that again. I'm just going to hope it's right because I know y'all are getting tired of this. Multiply that by 1.875 with an exponent of -3. And I get, which I hope is right, that's pretty large molar mass, 5.17 to the -1 or just 0.517. And make sure you label that's your grams of silver carbonate. Okay, a little bit messy down there. Grams of silver carbonate. Now, stoichiometry problems can be long, right? First really long problems you had in chemistry, I think. So we're not done with this one yet. All right, let's go back up and look back at the question. We've got the limiting reactant. We've got the mass of the precipitate. We need to know the concentration of all ions remaining in the reaction. Okay, so I need to know how much of each is left. Well, that's cool because you know what I know? I know how much of each I started with, and I know how much of each was used. Let's see if we can analyze this data. All of these numbers we have. Good thing I have them labeled. Just kidding, I have to enjoy myself, guys, because I've been doing this for like 3.5 hours. I've been making videos. And it's Saturday morning, and it's 10 o'clock. I got up at 6:30. I've been doing this for a long time. So I have to keep myself entertained. Okay, so we know that we started with 3.75 times 10 to the third moles of silver. We know that silver was our limiting reactant. Therefore, all silver was used and none remains, right? So the concentration of our silver ion is, there is none. It was all of it was put into the precipitate. There are no ions floating around. Check. Let's look at our nitrate. I started with 3.75. Nitrate was not a part of my reaction. Oh yes, nitrate was a spectator ion. None of him was used. All of it remains. Nitrate, spectator ion, all remains. I have 3.75 times 10 to the -3 moles divided by the volume of my solution in liters. What is the volume of my solution in liters? Well, it looks like it's 25 milliliters plus 25 milliliters. Sorry, a lot of work. Glad everything's labeled. I've got 25 plus 25 equals 50.0 milliliters divided by 1,000 milliliters per liter. Oh, I don't need to put that in my calculator. 0.050 liters, right? And when we divide that, we will have our concentration of nitrate ions floating around in the solution, and our concentration of sodium is 7.5 times 10 to the -2, my bad, -2 molar. That is an answer to that. Whereas that is an answer to that. Okay, what other ions did we have? Right, we've taken care of that nitrate. Check. Sodium. Oh, sodium, we started with 7.5. Did I just write sodium down there? No, but I did up here. I was supposed to, okay. Sorry, y'all figure that out. Told you it's been 3.5 hours. Sodium, we started with 7.5. And sodium as nitrate was, I was supposed to do nitrate a minute ago. Sodium is also a spectator ion. So all of him remains. And what do we have? We have 7.5. So our sodium, stop. Sodium ion, we have 7.50 times 10 to the negative third moles. The volume here is the same, right? Once you get it once, you got it. Divide that. 7.5 second E negative 3 divided by 0.05 equals 1.5, 0.150 molar. All right, got that. That's the answer to that. And we've got one more ion, that is our carbonate ion. Well, carbonate, some of him was used because he participated in our reaction, right? He participated. He was our excess reactant, remember? So some was used and some was left over. Well, this is how much I started with, right? I started with 3.75 moles of carbonate. Right? And I reacted that with, let's go back here. I reacted that with silver, okay? So let's see how much carbonate was required to react with that silver, okay? And that will tell me how much I used. There's so many different ways I could do this, but isn't it true that every 1 mole of carbonate reacted with 2 moles? Something's wrong. Something's wrong. Oh, that won't work. I can't start anything with my excess reactant. I'm so sorry. That will not work. Excess reactant gives you nothing. Okay, I knew something was wrong. So I know, what I know was my limiting reactant, right? This, never start a T-chart with your excess reactant. Won't tell you anything. This is how much reacted, right? What I know, I'm sorry, is that 3.75 times 10 to the negative third moles of silver reacted. I don't know how much carbonate reacted. I know how much I had. I know that every 2 moles of silver required 1 mole of carbonate. All right. Therefore, half of this reacted. Okay. What was, we said that was 1.875, 3.75. You should be putting this in your calculator too. Don't depend on me. Yeah, 1.875. It was 1.875 times 10 to the negative third moles of CO3 to negative reacted. Right. Well, we know that we had 3.75 times 10 to the negative third moles. We know that essentially we used half of it. Right. So we know that 1.875 times 10 to the negative third moles of CO3 to negative remains. All right. No, that is not our concentration. So the concentration of the carbonate ion is equal to 1.875 times 10 to the negative third moles divided by the 0.0500 liters equals, divided by 0.05 equals 3.75. times 10 to the negative second molar. Long video, long morning. All right, so that is that. Solution stoichiometry. There's nothing else to it. Done. Let's hope that didn't take too long. It's bright out now. The sun is out. It was dark.